It is my pleasure and privilege to introduce Dr. Kimberley R. Dr. Miner is a scientist and system engineer at NASA Jet Propulsion Lab in California. Dr. Miner is a scientist and systems engineer, where she researches and forecasts climate risks. Her work has taken her to most extreme environments in the world, from Antarctica to Mount Everest, where her team secured a Guinness World Record for identifying the highest altitude pollutions. Dr. Miner's research has been highlighted by CBS, the New York Times, Washington Post, GQ, and Sports Illustrated. Before coming to NASA, she worked with the Department of Defense in Washington, D.C., addressing climate risk to national interests. Please give a hand to Dr. Miner.
Hi, everyone. It's lovely to be with you today. Can you hear me all right?
Yes.
Okay, great. So I'm sorry that I can't be with you in person, but I'm really glad that I get the opportunity to chat with you today. I'm going to go ahead and share my screen and start the presentation. It will take me just one moment. Okay. And I'm assuming that if I don't hear anything that you all can see and hear me. Do let me know if that's not true. Today, I'm going to be providing some context for the rest of the symposium about what we're talking about globally, what the climate tipping points are. This is a point of conversation for all of us in my field in climate science. We're very, very interested in trying to understand and forecast what climate tipping points are emergent and what this could mean for global stability. So I'm going to get into what all of this means, but the first thing I want to do is start with a reminder. If you remember one thing from this talk today, please let it be that the work that you all are doing and the conversations that you are having around the sustainability of building and doing passive and making all of this huge change happen is critically important. Okay, you all are making the difference, and this is a really big part of this conversation. So I'm glad that we're all here together. So I'd like to start with a little bit of a story. You may have heard of the HMS Terror. This was one of the European ships that sailed to the polar north in the 1800s and was stuck in the ice, just absolutely trapped in the ice. There's a quote from Captain John Franklin saying, "Weary of being mired in ice, we abandoned ship and began making our way to Back's Fish River. Thence we hope to England's green and pleasant land." Unfortunately, they really didn't know where they were going, and many of them perished. Some of them were rescued by the local Inuit groups, but most of them were not able to make it through that summer. Okay, remember this is June 5th. Well, the HMS Terror was recovered just a few years ago in 2015. And the warm days and ice-free seas allowed divers to actually dive down to where the HMS Terror sank. And this was in late summer, in August and September. You can see this huge difference that's occurred only in 160 years later between being mired in the ice all summer long and not being able to move around at all to being able to dive to the bottom of the sea only 160 years later. So this is emblematic of a tipping point. So what is a climate tipping point? Tipping points are the way that we're talking about thresholds, things that we are going to cross in an ecosystem, in a global system, whether it be hydrologic, just soil, plant, the way that it all fits together, that we would cross these thresholds and things would not return to the way that they were. So in some systems, some of us are arguing that this may have already occurred. The Arctic may already have crossed the tipping point. It may never be the kind of same structure that we are used to in the most recent modern human system. We've got cold ice in the summer, and then you've got permafrost lying underneath. One of the things that we're going to be talking about today is that these changes magnify and they add up. So the more and more tipping points that are crossed, the more and more it's difficult for us to get back to where the system was. If you think about even just the heat abnormalities that are happening in the most recent time period, in the last summer, and even right now in some parts of the world, you can see that these small changes are starting to make big effects on the landscape. And the way that we often think and talk about this as climate scientists is as a snowball rolling downhill. It just gets bigger and bigger and bigger and faster and faster and faster until suddenly you're at the bottom of an avalanche. And this is what tipping points could look like on a global scale. Small disturbances, little things, temperature abnormalities, change in precipitation, change in vegetation, cutting down the Amazon, lead to tipping points. This was a really excellent paper that was put out very recently by McKay et al. And then the last person on the paper, which is sometimes how we say whose lab it is, was Linton. And he was one of the first people to really talk about tipping points in this community. And this is indicative of some of the things that we are watching as scientists and are pretty concerned about that could be changing in the Earth system. I'm not going to get very deep into most of these, but it would be very interesting if you wanted to read the paper or, have discussions afterwards. You can see there's a lot of changes going on in the Arctic winter sea ice, the boreal permafrost, the monsoon changing, and there's thresholds to this. Now, these are our best guess thresholds. We haven't ever been in a climate state like we are in right now with this very rapid warming. The rate of warming is more than it's ever been in Earth history, as far as we can tell, more rapid. And so we're not really totally sure what the thresholds are. Unfortunately, we may find out when we cross them. But part of what you all are doing and part of what the goal is right now globally is to make sure we don't get to 2 degrees Celsius. We don't get to 4 degrees Celsius. And that way we won't have to find out what these tipping points are. So let me see if I can click on this. Some of the things that we're watching include Arctic tipping points, like the loss of sea ice. I thought that this visualization was really stark because it really gives you an understanding of the way that the old sea ice is melting every year and being replaced by younger sea ice that has a lot shorter lifetime. So you can see that the ice that's over 9 years old is pretty rapidly, actually, I would say slowly in the visualization, but it's actually pretty rapidly leaving and being replaced by ice that's 1, 2, 3, 4 years old. And what that basically means is this really long-term stable ice is being gradually replaced until we won't have very much anymore. I am going to go ahead and let this finish because you can see it gets pretty stark as we get closer and closer. And some of the most rapid changes have been in the last 15 years. Again, the changes are continuing to speed up. Now, another thing that we're thinking and talking a lot about is soil tipping points. So, all of our food comes from the ground. I think everyone's very clear on that. But there's nutrients and microbes that build the structure of all of these soils and also give us the nutrients that we need in our food. Any kind of erosion due to over-farming, due to implementation of chemicals that are not sustainable, all of that can make unstable systems that don't provide the quality and quantity of food that we have been used to in the last 100 years. You can see this is a map of soil erosion over time from Schultz et al. In 2016. It's obviously outdated by 6 years, but already in 2016, there were significant areas where land was either unproductive or falling to soil degradation. So were a tipping point to be crossed in soil, it could potentially impact the global food system in really significant ways. Now, I think everyone is pretty more familiar with the coral tipping points. We've heard a lot about the Great Barrier Reef. I don't know about you, but I've seen some Instagram reels recently where people are taking pictures of themselves in front of the Great Barrier Reef, not realizing that the coral behind them has actually perished. Remember, coral is a living thing, but it also really creates a wonderful structure for ecosystems like you can see on the left. With more acidification of the oceans and also warming temperatures, we're having more and more die-off of this really essential structural component of the ocean. So that's also something that scientists are very concerned about because it's unclear what the changes would be to the ocean if we were to lose the underwater ecosystem. And it's unclear if we would really even know until it was too late because, we don't live in the ocean. So The planet is heading towards multiple tipping points. That's kind of the take home from what we have been talking about. Disasters do speed up the changes. As you have noticed, we've had a lot of disasters recently, be it huge forest fires in Alaska, many, many hurricanes. And what that does is it kind of punctuates and it makes the changes a little bit more rapid. The prolonged fire season that now has become seemingly global because it's happening even in the North Pole. Like I just mentioned, the hurricane season, and this is from last year. I have not updated this graphic with this year's, simply because there is still the potential for some hurricanes, even though we're outside of the season. Storm surge and sea level rise is a growing issue, and you may have seen about Antarctic Thwaites Glacier, an ice sheet that, if lost, would cause really significant sea level rise as it melts. And then the loss of ice, like I was just mentioning, that's driving a lot of these water changes and could change the stratification of the ocean, the temperature of the ocean, and the overturning circulation. So this is the context for the climate crisis, as many of us are calling it, that it makes this really important. It makes everything that you're talking about right now, today, tomorrow, super urgent, super critical, because it's very unclear how far the system will get towards tipping points and towards collapsing before we notice. There's a very macabre saying about a frog in boiling water, I'm sure you're all familiar with. Well, in this case, we are that frog. We are the people who have already experienced huge changes. The ecosystem I was born into is completely different than the ecosystem my father was born into. But I don't necessarily know that I could point out the differences, because it's not necessarily entrained in the way that we understand the world around us. So part of what I do want to do is give you the tools to understand where we're heading, and also make sure that you are thinking about the way that we can help, not only in your field and industry, but in, we've got elections coming up. We can talk to our representatives, we can talk to each other, build community, build school networks, and think about some of the trends that could be really supportive. So energy is changing. There have been a number of different reports recently that there are countries all over the world who are able to satisfy all of their energy needs with renewables just this year. And you can see this really globally throughout publications and throughout reports. A lot of the countries are European at this point, but there are also states that are doing a really good job with this transition. Carbon sequestration is an ongoing conversation. I point this one out, CarbFix, because it's one of my favorites. It doesn't involve throwing anything into the ocean, which I think is just a horrifying idea. But instead, we're able to potentially take CO2 from the atmosphere and trap it in basaltic rock, which sounds pretty darn good to me. It's not scalable yet, but it is something that folks are definitely working on, especially in Iceland. There's also a huge conversation going on about geoengineering, and I bring this up because there's many of us who are very concerned about geoengineering. Putting mirrors out in the atmosphere is probably not one of the ideas that would actually happen. It's a little silly, but there's lots of talk about throwing iron into the ocean to create greater uptake potentials without knowing the secondary or tertiary impacts of something like that. So again, staying below 2 degrees Celsius, not dealing with any of these consequences and not having to worry about geoengineering would really be the best option. This is not exactly my area, and I know it's your area, so I'm not going to get too far into infrastructure needs. I'm going to let all of my colleagues who are speaking after me do that. But some of the things I wanted to make sure that are on your radar is permafrost thaw. This is ground that has in the past been frozen 2 or more years, and it covers 1/3 of the Earth's surface, the dry surface, and it's thawing. So there's a potential for really intense structural changes to happen in the future. Cold and warm snaps, as you're aware, have also really impacted the energy grids. This is from Texas when they had the cold snap a couple of years ago, these really intense heat waves that happened all summer in places that maybe don't have AC, maybe don't have any infrastructure to support the amount of AC that they now have to deal with. Drinking water contamination from outdated water infrastructure, or from poor management choices, as it was in the Flint situation. and then a move back towards more mass transit. I know in Los Angeles, where I am stationed, there used to be an incredible system of mass transit that was all ripped out to put in the highways that I'm sure you're all very familiar with for Los Angeles. So actually it would be getting back to the mass transit systems and not necessarily reinventing the proverbial wheel. Did you get the joke? So where do we go from here? Part of what I'm doing is talking to everyone about science all the time. You can see this is part of some statues that AAAS and the Smithsonian put out of 125 women in science. And we had the opportunity to talk to thousands and thousands of students and parents who came by about what we do and why science is important. And I would really encourage all of you to do the same, to talk about what you do, talk about why this is important, talk about what's going on with the climate, talk about everything you learn over the next couple days, and make sure that we're getting the word out to everyone about what's going on with the globe. And I'm also really inspired by all of the companies, and this is just a very small selection of them, who have made working on climate change, cleaning up the oceans, rebuilding sustainable infrastructure, rebuilding forests, part of their mission. And you can see that this has become a very important conversation over the last few years. There was a long time where I kind of felt like I was standing in the corner in a dark room talking to myself, but now it's very clear that the word has gotten out and people are very concerned about what's going on in the global climate. And again, sustainable building is a huge, huge, huge part of that, not just because of greenhouse gases, but also because of the world that we could all have if we live together in these beautiful houses that are, you know, healthy for us, healthy for our children, and healthy for the environment. I wanted to just make sure and put this in there because you'll see that buildings are 6% of the greenhouse gas emissions. So there is a significant difference that you can make if you transition away from greenhouse gas emitting buildings. And that's a big part of what I believe we are all going to be talking about over the next couple of days. So let me leave you with this. Just a couple of things that you can do. Feel free to take a picture or a screenshot of this slide. There's a couple different ways to contact me as well on it. So the things that you are doing to be a part of the solution right now are attending this meeting. You are sitting here and we are talking about climate change and we are talking about tipping points. This is a big deal. The next thing I would say is either today, tomorrow, or when you walk away from the conference, make a plan. How are you going to take small steps to integrate into whatever stage you are at in your career, whether it's learning more, getting more readings done, putting more passive into your designs, however you can slowly integrate some of these ideas. Think about how you're going to do it as soon as you walk away. Make sure that when you are meeting other people and talking to them while you're here and while you're in the community, that you're sourcing them for inspiration. This is the time for all of us to work together and to put our weird and unique and wonderful skills together. Maybe someone's really interested in Star Wars and it's really weird and super fun to talk to them, but maybe that gives you a brainstorm that could be really, really big deal. The last thing is also the first thing we talked about. Know that you're part of the solution, that being here today, that being a part of this conversation is the difference. You are making the difference right now. I know things are very challenging to hear about, to talk about. It's a hard time, but you are making a difference. And I hope that that's what I can leave you with here today. So thanks very much for your attention. I'm not sure if we have time for questions, but you know how to contact me. Have a wonderful, wonderful time.